Hello, my name is Calvin with Atlas ORV, and in this video I want to go over our design process on our radius rods and kind of explain to you what makes ours different and what makes them better. There are two reasons why our radius rods are better. The first is that we use a material called 7075 aluminum. Most other companies use 6061 aluminum, and the difference is 7075 is about twice as strong. So I'm just going to try to explain to you kind of how you can get those numbers. So when you look at a material, the strength of it is called the yield strength of that material. And so when you're looking at, like, say 7075, the yield strength of 7075 is 73,000 psi. And then if you compare that to 6061, 6061 has a yield strength of 35,000 psi. So if you take those two numbers and you divide 75,000 by 35,000 psi, you get about 2. So that's just saying that 7075 is about twice as strong as 6061. I'm an engineer, so I'm going to use a graph here to try to explain what yield strength is and why it is important. So yield strength is basically the point at which once you pass that yield strength, when you're stressing a part, it permanently deforms the part. So I'm going to show you here on the screen here. So I have just here a piece of 6061 aluminum, and I can bend this and it goes back to its original shape. So what that means is I'm still in, it's called elastic deformation. So I'm bending it and then it goes right back to its original shape. So if you look here at this graph, I'm staying in this linear part of the graph and I haven't passed my yield strength. Now if I take this piece of aluminum and I bend it past yield strength, now it doesn't go back to its original shape. So what that means is I've gone past my yield strength and now I'm into my strain hardening part of this curve, and this material will never be as good as it was before I stressed it, basically. So that's kind of the science behind the material that we choose for our radius rods, and that's important because when you're designing suspension parts, you want your unsprung weight to be as low as possible so that your suspension, your shocks and springs can push your tires back down to the ground and your tires spend more time on the ground versus in the air. The next reason that our radius rods are different and have more performance built into them is a tool we call finite element analysis. And what that is it's a software that allows me to take this radius rod and pull on it virtually. And then it creates a color map for me so I can see where the stress is in this part. And this is extremely useful in the design process because I can add material where I need to add material to strengthen the part, or I can remove material to kind of optimize it and reduce weight. What it does is it creates this mesh, and these are the actual finite elements of this part. So what it does is it uses a very complicated math algorithm called differential equations to basically simulate a load on this part. You can see here I've added a load of 12,000 pounds on this part. So I'm virtually taking this part and pulling on it with 12,000 pounds of force. And when you run this analysis, you get this really cool color map. And what this color map is showing me is the stress in this part. You can see I have a legend over here, and so dark blue is going to be close to 0 or no stress at all in the part. So this would be basically, it's not really seeing any stress coming out of this part. And then it goes up towards red, and you can see it changes colors there. So you can see here I have a lot of blue, that's totally fine. We're seeing no issues here. And then it starts transitioning into like a lighter blue, and then green, and then into yellow. So yellow here, we're not at a failure point. Our failure point is red. So when we see any red, that means it's failed. But we're starting to approach red or at least orange. So that means I want to probably back off and just say we're probably good at least up to 12,000 pounds on this part, which that's a lot of load for this size of a part. And it's all because of the design of this arch here. This arch is, you can see, pretty nicely distributing the load across this part. To kind of show you what happens if you're designing a part without finite element analysis, I have one of a competitor's arms here drawn in, and I just ran it through the same same simulation. But I was only able to pull this guy up to 4,500 pounds before it was really not performing beyond that. So you would probably start being concerned about failure mode at this point. So this study, I didn't run it yet, so I'm running this study now. It takes 30 seconds, not too bad. But you can see in this part here, only at 4,500 pounds. Also, this is 6061 aluminum. So at 4,500 pounds on this part here, we're already starting to approach orange. So that's where you don't really want to go much farther than that, just for a safety factor there. So they've got a lot of blue here, a lot of green, but this stress is not really evenly distributed because they have kind of like these really sharp corners here. It's just concentrating that stress on this part. So that's really kind of one of the underlying things about our parts is that you don't really see, but it really does make a difference. One other thing, benefit to having 7075 versus 6061 is we have a part that's almost 3 times stronger than a similar part out of 6061, plus it's lighter. So if I go into do a mass analysis of this part, I'm coming out with about 5.5 pounds for this part. And then if I go over to our part here, do a mass analysis on it, I'm getting about 5 pounds. So you're getting about 3 times the strength, and you're actually coming in with less weight. So I hope you learned a little bit from this video, and if you have any questions, feel free to reach out, and I hope you can consider putting some of these on your machine. Thanks. Bye.